In this video, we're going to be finding the exact value of trig functions using reference angles, and we're actually going to be sketching out each angle and then drawing special right triangles. So if you guys don't have a firm grasp on 30, 60, 90 triangles and 45, 45, 90 triangles, I suggest you learn that before watching this video. You can actually check out some of our other videos that walk you through how to solve problems involving those special right triangles. So if you guys do feel comfortable with special right triangles, then we can jump into example 1, which is the sine of 210 degrees. So what we want to do first is actually sketch out 210 degrees. So let me just fill in the degree measures on this diagram over here. So to the left is 180, and down here we have 270. And now we want to sketch 210 degrees. So 210 degrees is going to be right around here. And now we want to draw a right triangle with the x-axis. You always want to make a right triangle using the line you drew for your angle and the x-axis. So we're going to have a triangle like this. And now we want to figure out what this blue angle is right in here, because this angle is going to help us find the sine of 210. And the way we're going to do that is we want to understand that this pink angle is 180 degrees. So the pink one is 180 and the white one is 210. So to find the blue angle, we're going to do 210 degrees minus the pink angle of 180 degrees. And if we do that, we're going to get that our blue angle is 30 degrees. So I'm going to fill in 30 degrees right here, which means that this other angle in our triangle is 60 degrees. So we have a 30, 60, 90 triangle, and now we want to fill in the sides using what we know about the side length ratios for 30, 60, 90 triangles. And you should know that if your short side is 1, then your long leg is √3 and your hypotenuse is 2. And now what we want to do is think about what's actually the sign of these sides of our triangle. So like, is it positive or negative? So for this √3, we're going to the left. So that's going to be negative. So this is negative √3. And for the 1, we're going down. So that's also going to be negative 1. And our hypotenuse is always going to be positive. So now that we have our triangle figured out, we're just going to use this triangle to find the sine of 210. So we want to remember SOHCAHTOA. So we are looking for the sine of 210. So we know that the sine is going to be equal to opposite over hypotenuse. So for the sine of 210, we're going to use this triangle that we just drew, and we're going to use the 30-degree angle as our angle. So the side opposite of it is -1, and the hypotenuse is 2. So we get that the sine of 210 is -1/2. Let's go through some more examples. So for question 2, we have the tangent of 3 pi over 4. I think it's easier to deal with degrees. So what we're going to do first is change 3 pi over 4 into degrees. So remember, to change radians to degrees, you are going to multiply by 180 over pi. And when we do this, the pi's are going to cancel out. And now we're going to want to cross reduce this 4 and this 180. So I'm going to divide them both by 4. 4 divided by 4 is 1. 180 divided by 4 is 45. And now we're going to multiply 3 by 45 to get 135 degrees. So this is the same as the tangent of 135 degrees. And now let's label our degrees on our diagram. So 135 degrees is going to be right around here. So it's going to be like that. And I'll write 135 degrees. We're going to draw a triangle in with the x-axis. And now we want to find this blue angle right here. So what we want to understand this time is that this entire pink angle is 180 degrees. So to find the blue angle, we're going to do the pink angle, which is 180 degrees, minus our white angle of 135 degrees. And we will get that our blue angle is 45 degrees. So let me just erase this pink angle. So we know that our blue angle is 45 degrees, which means we have a 45, 45, 90 triangle. And now we just want to fill in the side lengths based on what we know about the ratio of the side lengths for 45, 45, 90 triangles. So you should know that if your legs are both 1, remember a 45, 45, 90 triangle is isosceles, so the legs are the same, then your hypotenuse will be the square root of 2. And now we want to think about what are the signs of each of these sides. So the 1 on the horizontal is going to be negative because it's going to the left, and the 1 for the vertical is going up, so it's going to stay as positive 1. And now we want to find the tangent of 135 by finding the tangent of this blue 45-degree angle. So you're always going to be looking at the angle in the triangle that is made with the x-axis. So let's remember SOHCAHTOA. We are doing tangent. So we know tangent is opposite over adjacent. So in this case, our opposite side is 1, and our adjacent side is negative 1. 1 over negative 1 is negative 1. So we get that the tangent of 135 degrees is equal to negative 1. Let's keep going through some more examples. So example 3 is the cosine of negative 45. So let's just sketch in our quadrant angles. So because our angle is negative, we are going to go clockwise this time from the x-axis when we're drawing it. So negative 45 is going to be right here. So it's going to go backwards like this. And this will be negative 45. And we're going to draw a triangle in. And we don't actually care that the angle is negative. So I'm going to actually erase the negative, and we just know that this little angle in here is 45 degrees. And now we want to fill in our side lengths of our triangle. So we know that a 45, 90 triangle is 1, 1, root 2. And let's figure out what the signs are of those sides. The horizontal side is going to the right, so it's positive. The vertical side is going down, so it's going to be negative 1. And our hypotenuse is always positive. And now we just want to use SOHCAHTOA to find the value of the cosine of negative 45 by using the cosine of the 45-degree angle that we just drew in this triangle. So if we're looking at this 45-degree angle in blue, and we want to do cosine, we know we have to do adjacent over hypotenuse. In this case, our adjacent side is 1, and our hypotenuse is the square root of 2. And now we just want to get the square root of 2 out of the denominator. So we want to multiply the top and bottom of our fraction by the square root of 2. On the top, 1 times the square root of 2 is the square root of 2. On the bottom, root 2 times root 2 is just 2. So we get that the cosine of negative 45 degrees is the square root of 2 over 2. Let's keep going through some examples. So for this example, we have the secant of 11 pi over 6. So what we want to start by doing is changing 11 pi over 6 into degrees. So we have 11 pi over 6. We're going to multiply it by 180 over pi. We're going to cross out the pi's, and we want to cross reduce 6 and 180 by dividing them both by 6. 6 divided by 6 is 1. 180 divided by 6 is 30. And now we want to multiply 11 by 30. 11 times 3 is 33, and then we have that 0. So we get that 11 pi over 6 is 330 degrees. And now we want to go over here and sketch 330 degrees. So 330 degrees is going to be somewhere over here. We're going to draw on our triangle. So to figure out what our blue angle is, we're going to have to do this entire angle of 360 degrees minus our white angle. So we're going to do it over here. So we're going to do 360 degrees minus the white angle, which is 330 degrees, is going to give us a blue angle of 30 degrees. Let's just erase this pink angle. So we know our blue angle is 30 degrees. And now we have to fill in our triangle, knowing what we know about 30, 60, 90 triangles. So our short side is 1, which means our long leg is root 3, and our hypotenuse is 2. Because the root 3 is going to the right, it's positive. The 1 is going down, so it's negative. And the hypotenuse is always positive. And now we are finding the secant. So what you have to remember is that the secant of an angle is equal to 1 over the cosine of an angle. Or you can think about it as they are reciprocals. So if we look at SOHCAHTOA, we know that cosine is equal to adjacent over hypotenuse. The secant is the reciprocal, so that means it's equal to the hypotenuse over the adjacent. So the hypotenuse of this triangle is positive 2. The adjacent side is the square root of 3. And now we just want to get rid of the square root of 3 in the denominator. by multiplying the top and bottom of our fraction by the square root of 3. We get 2 root 3 on the top. On the bottom, the square root of 3 times itself is 3. So we get 2 root 3 over 3 as the secant of 11 pi over 6. Let's go through 2 examples where our angles are bigger than 360 degrees. So for number 5, we have the cotangent of negative 510 degrees. So what we want to do first is sketch this. So let's fill in our quadrant angles. And we know that 0 is also 360. So if you go around a full rotation, you'll hit 360. So for negative 510, we have to go in the negative direction, so clockwise. We have to go a full negative 360 degrees around, and then we still have to go an extra negative 150 degrees. So we're going to have to go an extra negative 150, so right about there. And to find this blue angle, we know that this angle right here was an extra negative 150 degrees. And we need to get to negative 180 degrees. So you can kind of think of it as we went 150 and we need to get to 180. So we have 30 degrees left. So this little blue angle right here is 30 degrees. So that means we have a 30, 60, 90 triangle, and we're going to fill in our sides. So we've got 1 for the short leg, root 3 for the long leg, 2 for the hypotenuse, and we have to figure out if our legs are positive or negative. They're both going to be negative because we are going to the left and down. So we have negative root 3. And negative 1. And now we have to remember that cotangent is equal to the reciprocal of tangent. And from SOHCAHTOA, we know that tangent is equal to opposite over adjacent, which means cotangent is equal to adjacent over opposite. So for the cotangent of negative 510 degrees, we need to do the adjacent side, which is negative root 3, over the opposite, which is negative 1. 2 negatives cancel out, so we have root 3 over 1, which is just positive root 3. So we get that the cotangent of negative 510 is root 3. Let's go through one final example where we have an angle bigger than 360 degrees written in radians. So for this last example, I encourage you guys to pause the video and try it on your own. Then you can watch me work through it to make sure you've done it correctly. So because we're in radians, let's start by changing this to degrees. So we have 8 pi over 3. We're going to multiply by 180 over pi. Cross out the pi's. Let's cross reduce 3 and 180 by dividing them both by 3. 3 divided by 3 is 1. 180 divided by 3 is 60. And 8 times 6 is 48. So 8 times 60 is 480 degrees. So this is the same as the secant of 480 degrees. And now let's sketch 480 degrees over on the right. Remember, 0 is the same as 360 if you go around a full rotation. So for 480, we have to go a full 360, and then we still have 120 degrees left to go. So it's going to be somewhere around here. So we know that this part right here was 120 degrees. So our little blue angle right here is 60 degrees because 120 degrees is 60 degrees away from 180. And now we're going to draw on our triangle. So we've got a 30, 60, 90 triangle. Short side is 1. Long leg is root 3. Hypotenuse is 2. The short leg is going to the left, so it's going to be negative 1. The long leg is going up, so it stays positive. And now we have to find the secant. So we have SOHCAHTOA. And we know that secant is equal to 1 over cosine. Since cosine is adjacent over hypotenuse, the secant is just the reciprocal, so you flip it upside down to get that the secant is hypotenuse over adjacent. So in this case, our hypotenuse is 2, our adjacent side is negative 1, and 2 divided by negative 1 is negative 2. So we get that the secant of 8 pi over 3 is equal to negative 2. So hopefully this video helped you guys understand how to find the exact value of trig functions using reference angles. You really just want to understand how to draw the angle, and then you're going to have to understand special right triangles to find these values. And if you guys want some more practice with problems like these, check out the link in our description for a free practice worksheet.